Section 6, Video 4. So now we talked about having the ability to solve a system of equations by graphing, which gives you an approximate answer, by substitution, which means you have to solve one of the equations for a variable and then substitute that into the other equation, and elimination, which means we have the two equations needing to be in standard form, looking for opposites so that when you add them together, one of the variables cancels. But what if you aren't given the directions to use one or the other, and you have a choice? Well, substitution is best if you happen to have one of the equations solved for a variable already. Elimination is best if you have the two equations in standard form and you notice that there's some opposites so that when you add them vertically something cancels. So again, being strategic and efficient at the same time. The first equation, notice that you have one equation solved for a variable. So again, you can make it work for elimination by making some changes, or you make the observation that it's already set up for substitution, so you should use that method. Next equation, here you have two equations solved for a variable. Not just one, but two, which actually gives you more choices when it comes to solving by substitution. You can plug either equation into the other. Definitely, this one is a substitution. The next one, neither one of them is solved for a variable. That's a negative towards substituting. That wouldn't work. You'd have a lot of work to do. It's lined up in standard form. So this one, elimination, probably would be your most efficient process. So again, your choice. So look at each question. When you don't have directions to solve by one method or another, look at the problems carefully. Look at it strategically and efficiently to see what method would be best used based upon what you're given. Knowing that you could do either, but sometimes one method would need more prep work than the other. So this ends Section 6, Video 4.